Okay, all right, so in example 3 now, it says use the following information to find x and the length of the given measurement, okay? So the key here is to draw first what we're given, and then from there, label the picture and set up the equation, all right? So we have some algebra in here. So this first example says point B is between C and D, okay? So let's go ahead and draw that, all right? So we have point B is between points C and D. So that means C and D have to be our endpoints, and point B is in between them. Now this is just a quick sketch, all right? We don't really know how close point B is to C or D, all right? But we just know that it's in between there somehow. So CB has an expression of 4x minus 9. So what I'm going to do is come down here and label this segment 4x minus 9 right here. Okay? Then I'm given that BD has an expression of 3x plus 5. So this segment right here. And then the full length of CD, so this full length right here, is 17. So what are we going to do in order to find x? Okay? Well, we're going to do the segment addition postulate, which says that we can take the length of CB, add it to BD, and then set it equal to CD. All right, so I'm going to write that out. All right, so the length of CB plus the length of BD is going to be equal to the length of CD. All right, so the expression for CB is 4x minus 9. So I'm going to write that in for CB. Plus the length of BD is 3x plus 5, which is going to equal the full length of CD, which is 17. And now we're just going to solve this equation, all right? So we're going back to algebra for a second. So let's combine like terms. I have 4x and I have 3x, and that's going to give me 7x. I have a negative 9 plus 5, which is going to give me minus 4, is equal to 17. Okay? We have to get rid of the minus 4 first, so we're going to add 4 to both sides to cancel that out, and we're left with 7x is equal to 21. We're going to divide out that 7, and we're going to get x is equal to 3. So that right there is our first answer, all right? Because the question is saying find x, but then it's also saying to find the length of the segment, okay? Now that's going to be a numerical value. So in this example, it says to find the length of CB right here, okay? So if CB is the expression 4x minus 9, how can I use x in order to find the numerical value of CB? Well, we can take that 3 and plug it into that x and then simplify, right? Which is exactly what we're going to do. So I'm going to take that 3, plug it in. So I'm going to have 4 times 3 minus 9. 4 times 3 is 12 minus 9, which is 3. So the length of CB is equal to 3. Let's try the next one, all right? So let's draw our picture, and it says point H is between B and K. So I'm going to go ahead and draw that. So put my endpoints and the point in between. All right, and remember, that's not right in the middle. All right, it's just somewhere in between, okay? And it says H is between B and K. So I have H, B, and K. All right, so BH is given to us as the expression of 2x plus 1, and I'm going to go ahead and put that in my picture, 2x plus 1. HK is 3x plus 10. I'm going to put that in my picture. HK is 3x plus 10. But then we are given that this full length of BK is 8x minus 22. Okay. So segment addition postulate says that we can take this length of BH add it to this length of HK, and set it equal to the full length of BK. All right, so let's write that out. So the length of BH plus the length of HK is going to be equal to the length of BK. Okay. All right, so plugging in our expressions, BH is 2x plus 1 plus HK, which is 3x plus 10, is equal to the full length of BK, which is 8x minus 22. All right, let's solve this equation. So we have 2x plus 3x, which is going to give us 5x. We have 1 plus 10, which is going to give us plus 11, equals 8x minus 22. Okay, now let's just do a quick reminder. All right, this is variables on both sides, okay? So what that means is that we need to move our variables to one side. All right, and I typically like to move them over to the left-hand side, okay? So I'm going to subtract 8x on both sides, and I'm going to get negative 3x plus 11 equals, and the 8x's cancel out, which was the goal, and then I'm going to bring down the negative 22. All right, getting rid of that 11, I'm going to subtract 11 on both sides, and I'm going to get negative 3x is equal to negative 33. All right, dividing out that negative 3, we get x is equal to 11, which is the first answer that we need. Okay? Now, it also says to find the length of BK, all right, the numerical value for BK, okay? And we're given this expression that BK is 8x minus 22. And if I know what x is, I'm going to take that 11 and plug it into that expression and then simplify, all right? So I'm going to get BK is equal to 8 times 11 minus 22. Oh, I'm running out of space. Okay, 8 times 11 is 88 minus 22, which means that the length of BK is equal to 66. And that's our final answer. Okay, so our last term in here is congruence, all right? And what the definition of congruence means is that it's the same size and the same shape, okay? Now, when we're talking about congruent segments, all right, these are just segments that have the exact same length. All right, so let me give you an example for that, okay? So let's say I make this segment right here, okay? Let's put our two endpoints on, and let's call this A and B, okay? Now, I'm going to make another segment that appears to have that same length. Put those endpoints on there, call them C and D. Okay, so I'm going to tell you guys that these two segments are congruent, all right? So there's two ways to communicate that, all right? The first one is on a picture. To show that segments are congruent, you can make these little tick marks, all right on the segment, and those tick marks are going to say that these two segments are congruent, which means that they have the exact same length. All right, which means that if AB has a length of 10, that means that CD also has to have a length of 10, okay? If AB has a length of 15, then CD also has to have a length of 15, okay? Now, another way of communicating that these two segments are congruent is by writing it out, okay? So there's a symbol, all right, that means congruence. And that symbol is an equal sign, but it has this little squiggle on top of it, all right? So that symbol right here means congruence, okay? And the way that I would use that is I would say segment AB with a hat on it, all right, with that little line on it, is congruent to segment CD, and that's how I would utilize that symbol, okay? So two different ways. You can either use the equal sign with the little swiggle on top, or those two little tick marks, all right, and that's going to say that those two segments are congruent. So let's look at example 5. All right. So example 5 says determine if you have enough information to prove the following segments as congruent. And we are looking at segments AB and CD. Okay. So let's go back to our definition of congruence. So congruence again means that segments that have the exact same length, right? So if you notice, CD has a length of 5 centimeters. AB also has a length of 5 centimeters, which means that they have the exact same length. And if they have the exact same length, we know then that segment AB is congruent to segment CD. Okay? And I just put those little tick marks to state that yes, these are congruent. I'm also going to practice just by showing you I could also state AB. Segment AB is congruent to segment CD. And that's another way. Okay? And we know that because they have the exact same length. Now, let's go ahead and try an algebraic example, all right, using this idea. So example 6 says point T is between M and O. All right, so we're going to go ahead and draw that. Okay, so that means if T is between M and O are your endpoints. Okay, now it also says that segment MT is congruent to segment TO. All right, so notice what I just marked there, okay? Segment MT is congruent to segment TO, which means that they have the same length, okay? Now, MT has an expression of 3x plus 1, so I'm going to mark that on my picture. And TO has a length of 5x minus 22. So then it says to find the measure of TO, all right? But first we have to find the measure of X, all right, in order to find the numerical value of TO, all right? So this one's a little bit different than the ones we did before because we were always given each individual segment and then we were given the full segment, right? And we don't have that, all right, which means that we are going to have to use our vocabulary. So if we know that they are congruent, we know that they have the same length. All right, and if they have the same length, we know then that 3x plus 1 is equal to 5x minus 22, okay? Which is going to be my equation. So I know that 3x plus 1, is equal to 5x minus 22. And now I'm going to solve, all right? So just like before, I'm going to move my variables to the left-hand side. It doesn't matter which way you move them, all right? So I'm going to subtract the 5x, and I'm going to get negative 2x plus 1 is equal to negative 22. I'm going to subtract the 1 on both sides, and I'm going to get negative 2x is equal to negative 23. Okay, and then I'm going to divide by a negative 2, and I'm going to get x is equal to 11.5. Okay? All right. Now, the last little bit, though, says to find the measure of TL. So how are we going to do that? Well, we have the expression for TO, which is 5x minus 22. We have what x is equal to, so I'm going to take that 11.5 and I'm going to plug it in, all right? So I'm going to have TO is equal to 5 times 11.5 minus 22. And now I'm going to solve that. So I'm going to do 5 times 11.5, which gives me 57.5 minus 22, which gives me 35.5 as your length of TO. And that is our final answer, okay? All right, so if you guys have any questions, let me know, all right? Otherwise, good luck on the quick assessments and really study your vocab.